This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts.
Get a free copy of Altium software using the link provided in this video description. Plus, when you sign up for an Altium Designer free trial, you will get Altium 365 and 25% off discount. Hi, and welcome again to another video. Today, we're gonna learn how to design a simple acceleration sensing alarm using ADXL337 using Altium Designer. So this board is quite simple and uses a few discrete components to operate. It includes only a resistor, an acceleration IC, a buzzer, op-amp IC, capacitor, and a power source. Accelerometers are sensor that is used to measure acceleration of itself or the object where the sensor is fixed to. It is capable of measuring acceleration occurring due to external forces applied and also the gravity. This acceleration sensing alarm circuit will sound the alarm when the object to which it is fixed exceeded a certain acceleration level. We can use this circuit in vehicles, toys, even as a wearable for controlling acceleration. So now, let's start designing it using Altium Designer. First, you should have a PCB project file. In order to have a PCB project file, click on File, New, then Project. Then, you can set here the project name and the folder in where you want to save your project. So for this case, let's put acceleration sensing alarm using ADXL337. Then click Create. Next, you need to create a schematic doc. Click again on File, New, then Schematic. After the schematic sheet appear, save the schematic doc. Right-click on the schematic doc, then click Save. Save it to the same folder. Next, we're going to create a library. Click on File, New, Library, then Schematic Library. Save again this one. Next, PCB library. Click on File, New, then Library, then PCB library. Save again this one. Now for this PCB, we will be using a library loader. So go back again to schematic doc. Make sure that you're always in the schematic doc and click on the library loader. So this is available on the internet, and we're just gonna copy the manufacturer part number of each component here in the search tab and just click add to design, and it will automatically load in our schematic sheet. So this is the BOM list for this PCB, and these are the part numbers of each component, and we're just gonna copy each part number. Let's try this one, copy this one, then go back to schematic doc, open the library loader, and paste it in the search tab. Then click on search, wait for it to load, then click on the result and click add to design. Now as you can see, it automatically added in the schematic doc, and if we check on the schematic library, you can see that it is added on the library. So, next thing we need to do is to edit the comment. So, since this is a terminal block, we will put here the value of the component. So, save this one. So it is much better to edit the comment because as you can see, it is much more readable if we place it in the schematic doc. This is the original one and this is the edited one. So repeat the same process in all the components in the BOM list until you complete all the libraries. After you finish all the components in the BOM list using a library loader, you can check here in schematic library panel all the added libraries. So these are the added libraries for this PCB. Next, we're going to put all of this in our schematic doc. So go back to the schematic doc and click on Components. If there is no component in your panel, just press K in your keyboard, then click on Components. Now you can see here the library for this project. So we're just gonna drag the library inside the schematic sheet. Next, we need to set the designator of each component. So there are two ways in setting the designator of the components. We can set it manually by double-clicking the components and edit manually the designator. Or we can do it in automated way. Just click on Tools, Annotation, Annotate Schematics, then click on Update Changes List, click OK, and as you can see on the proposed column, here are the assigned designator. So click on Accept Changes, Create ECO, then click Execute Changes. Close all the tabs, and as you can see, the designator on each component has been assigned. Next, we're going to put the connection on the components. So to put connection, click Place, then Wire. So snap it in the pin of the component and connect it to the other pin of other component in where it should be connected. Now as you can see, we have a small circuit and a huge schematic sheet. Now we're going to edit the size of our schematic sheet. Just go to Properties panel, change the units to mm, and click on Custom. Now this is where you can set the width and the height of the schematic sheet. So this is the finished schematic, and before we go to the placement, make sure to always perform validation. So just right-click on the project PCB file and click on Validate. Then to check the result, go to Message panel. As you can see, no errors found. So now we can perform engineering change order. So before that, we need to create the PCB. Click on File, New, then PCB. Next, save this one. And go back to schematic doc. Now we can perform engineering change order. Click on Design, then Update PCB document. Now the engineering change order dialog box will appear, and it will show all the components, nets, and classes that will add on our PCB. Just click on Validate, then Execute. Now we can start with the placement. So these are the components, and just drag it inside the PCB. After you place all the components inside the PCB, next we're going to edit the board shape. Just press 1 on your keyboard to activate this kind of view, then click on Design, then Edit Board Shape. Now, the snap points will appear. So we're going to drag it manually in accordance to your board shape. Now press number 2 on your keyboard to back in 2D view. Now as you can see, the board shape has been set. And now we can start with the layout. To add connection, just click on Route, then Interactive Routing. Click it to the pad of the component and snap it to the other end of other component in where it should be connected. Now we're done with the layout. To view it in 3D view, just press 3 on your keyboard. Now we're done designing a simple acceleration sensing alarm using ADXL337 using Altium Designer. So this design is just simple and easy to follow, and this video will teach you how to use Altium Designer for your future projects. This board uses a minimal set of components and the best simple design to start off. So stay tuned to other videos, and I hope you learned something from this video. Thank you for watching.